Well, great. Thank you. Morning, guys. Thanks for the opportunity to present on this session. So I'm Dave Gregory with NVIDIA. I'm based in the UK. I manage the Metropolis business, which is focused on computer vision, intelligent video analytics, and digital twins for the UK, Ireland, and Nordic region. So today, I want to share with you a very brief introduction into the NVIDIA Omniverse platform. There's a lot of information to condense in, so hopefully I do it justice in a short amount of time and to give you that overview. Just to frame that, I always talk about NVIDIA. A lot of people know us predominantly for the video game space, the graphic card space, but actually we're an accelerated computing company. And what that means is we operate in three broad domains. So graphics, simulation of light, what we're best known for, what most people know us for. High performance computing, so this is simulation of physics, chemistry, biology, those equations for scientific computing that require that high speed connectivity. And AI, machine learning, digital twins to help provide insights, gain understanding, patterns in data. So we're a full stack, so we have the hardware, the software to bring that all together, the tools for developers to build. And our objective there is to make and to speed up business applications, to make those workloads quicker, to save time, money, and resource. The full stack looks like this. Each one of these components is a different element of what we offer. Metropolis, where I sit, is just one of those. Omniverse sits under that. I'm going to talk about that today, underpinned by our software stack, our tools, our hardware that deliver this and enable all of this to come together. And you know, it's a foray. If you want to build a digital twin, if you want to build an avatar, you take one of these stacks. It gives you the tools to build and deliver applications in those areas. But let's focus on digital twin, the concept of metaverse, right? Connecting virtual worlds, or the extension of the physical world, and bringing those together. And really, the digital twin are those connected models that enable us to do that for industrial assets processing, for different environments. And the core there is to get the accurate and trustworthy data from that environment to enable us to deliver accurate simulation. And actually, we break that down into four key required components. Sorry, let me just adjust my screen here. Ground truth, so that single source of truth for those virtual data sets. Andy was just mentioning about that data, that complexity. The being physically accurate, so the objects that we simulate obey the laws of physics. The synchronization, so the precision, the timing, synchronized to the real world. And the AI piece, so being AI enabled, optimizing the AI and the training of AI based on that data. And I'll show you some of those examples here. And to enable all this, we've built Omniverse for this very purpose. It's a platform for building and simulating virtual worlds in real high fidelity that are indistinguishable from the real world. And we leverage all of that stack and all of that compute power to achieve that. So the Omniverse sits at the core of this journey when building a digital twin. And it brings together these components, so that full fidelity visualization and custom 3D tools. So in this example, aggregation of that full design, 3D data sets, the materials, the lighting, everything we need for that visualization in real time. And also it helps teams collaborate when building that data pipeline and that workflow. Physics simulation, how we apply that to those real life environments. I'm going to give you an example of how that works and some results we've seen from that. But using that and then using the AI piece to understand, can those physical attributes be predicted in real time for that high accuracy and high fidelity. We talk here about connecting and training autonomous systems as well. And again, I'll share an example with you when we look at robotics models. and how they could be trained on synthetic data pipelines that are created within our digital twins, and then also how they're connected to the real world. So bringing in live data, live system data, data streams from IoT sensors, for example. So Omniverse sits at the center of this and enables teams to collaborate and bring that all together. But Omniverse is not a tool. And this is the most common question if I'm talking to customers, I'm at trade shows, they talk about Omniverse digital twin. Say, oh, can I just download it and start doing all of the good stuff? It's not a tool. We're not competing with existing modeling, rendering, texturing materials and simulation tools. What Omniverse does, it's a connection fabric between all of these tools. It lets you aggregate that ground truth data from all of these different tools, real large ecosystem used by all of the world's leading industries. And it enables that collaboration to simulate, interact with it, and collaborate on a real high fidelity. There's many different ways to bring that data in. There's different types of connectors that enable us to plug into these applications, bidirectional connectors as well. So for example, if you're working in Revit on a lighting plan in Omniverse and you're looking at a building of your office, there's a model loaded up with the lights and you turn it on and you're trying to adjust the lights to see how things might look, how it affects your environment. You can make those changes in real time and your team collaborating on that can see that and how those changes are reflected immediately. I want to share just a few examples here, and there's many, and there's some links to share with you, but just a few listed here. Amazon Robotics, they increase their model accuracy, which saves them time retraining robotic precision systems. BMW did the same, building their factory, simulating that, resulting in more efficiency gains up to about 30% when they were building their factory. Ericsson designed their 5G networks. They can simulate real time in the city how their 5G antennas are placed and how that signal refracts off of buildings, speeds up deployments. PepsiCo streamlined their operations, building in a digital twin so they can understand how they could increase throughput, reduce energy usage, for example. And then also Siemens were looking at the impact of wind wake effects on buildings. And that normally took about 40 days, and they could reduce that to 15 minutes, doing that in a digital twin with the physics simulation. So some good examples there of how it's deployed. Hopefully this video translates here. This is just an example here of using some synthetic data in that digital twin. So here we're just very simple looking at forklifts. I want to train an AI model on forklifts. So how can I do that? I can do that in Replicator. I can build all of these different types of data sets here. I can do wonderful fancy things with them that you could never do in real life, which equates to being able to train an AI model which can then inference in the real world and to be much more accurate, but trained on a much wider data set. And we can do some crazy and weird and wonderful things to make that data set more full. Another good example here, one of our partners is looking at optical character recognition on a number plate. Okay, so how can we train AI in a digital twin to understand different number plates across the globe, different characters? Well, here, this is the application they built within Omniverse. It allows them to, you can see at the bottom there, simulate different times of day, different weather conditions, different lighting. They can go in and change the characters on the number plate. They can make the number plate bent, rusted, obscured. Again, to train their models here to build a more accurate AI model to inference in real world. So really, really powerful. This is using the physics engine here to generate that light and different simulation. So look, that's my time. There's so much to talk about on this subject. You know, I could talk for an hour or 5 about this. But look, it's just to summarize there. It's a tool for collaboration, connecting. It's this fabric behind all of these tools that everybody uses building digital twins. It's based on USD, so it makes it easy. We can import. We have a standard common format, lots of extensions, very customizable for developers, very scalable. It sits in on your desktop, in the cloud, in the data center, and fully supported. There's some links here that I will share. You can download the ebook. You can learn more. There's hands-on labs. You can try the software. You can get in touch with us for any information. So, yeah, that was a very condensed version of